Nerds, let's talk about the Adventures of Linq. Linq being System.Linq from C Sharp, not the Adventures of Linq, the fantastic Nintendo game from the late 80s, which you can see Link is normally Link from Zelda, Link, but I changed it to Linq because it's called Link. It's a pun. Get it? Dad jokes? Great. Moving on. So Linq does many, many, many things. We're only going to focus on this third part here. We're going to combine Linq with Lambda functions so we can get select operations, or if you're more familiar with like databases or, I guess linear algebra or something like that, this would be more like a project operation. And also a where, which is kind of a filtering operation, and aggregation functions, sum, count, things like that. But just keep in mind that Linq is actually much broader than that, and it lets you have a mechanism for reading data out of multiple different data sources like XML files or SQL databases, and it has a syntax that actually kind of looks like and is inspired by SQL. We don't have to use that syntax. There's actually another syntax we'll see, but we certainly can. Right, so there's a lot of really interesting functionality that comes along with Linq. Again, we're only going to use down here a small part of it. So before we talk about that, we have to do a quick review of the C# collections hierarchy. So Java also has a collections hierarchy. You have, collection, and then you have, iterable, and, list and things like that. C# similar. The naming conventions and the sort of coloring convention from this image, which here's my source for it, anything that starts with an I, a capital I, is an interface. And anything that doesn't and is in dark background color here, those are concrete classes. So IEnumerable, something that's enumerable just means you're able to iterate through it. But you don't necessarily have methods on something that's enumerable for adding and removing things. And so stacks and queues, that's what we've gotten for stacks and queues. And it's a little bit weird. You might be looking at this and thinking like, Spacko, that's strange. Like, you can absolutely add things to a stack. There's a push method, and queue has an enqueue method. But it turns out that the issue here is remove. Stacks don't really have a standard way of removing things. There's pop, but that's not quite the same as remove. And so for whatever reason, in the design of this API, they decided stacks and queues are enumerable, but they're not collections because collections have add, remove, and count methods. So that's just the distinction. Is this the best way to do this? I don't know, but it's how C# does it. If you look at Java's collections hierarchy, there's some quirks and idiosyncrasies in there as well. Anyway, more detail than you probably wanted to hear. So we've got IEnumerable. A collection can do everything enumerate can do, but you can also add, remove, and count elements. And then a list, obviously, is a kind of collection, but it's a collection that is ordered. And so you can kind of see these differences here. Hash sets, you can add, remove, and count things in a hash set, but it's not ordered, whereas a list is ordered. It's a little weird that linked list is a collection but not an iList. I think probably the difference here is anything that's an iList has to be backed by an array, so it has to have like constant time access to something that's in there. I'm not really sure. I didn't bother looking it up. I put some links to some other more information about these collections. So we're going to use this knowledge later, just sort of keeping in mind that the most general type of anything that's some kind of a collection is IEnumerable. You could always have a variable of type IEnumerable, and it could point to a stack or a queue or a linked list or any of this stuff out here, and the reference variable doesn't need to know. Now, the only thing you could do is iterate, which basically means a for each loop. Okay, moving on. So Linq, we can apply Linq to huge numbers of things in C#, arrays, lists, sets, and other collections. And so you can think of it as like a query system or a filtering system for selecting subsets of collections, or sort of taking all the elements of a collection and applying some function to them to change them. So to use Linq, you just say using System.Linq. So select, this is a projection operation in, mathematically. So it's going to build a new collection because we're going to apply some function to each element of an existing collection. Where is more like a filtering operation. You can think of this as restriction. So we're going to build a new collection by filtering the existing collection. So, at best, we could build a new collection that's an exact copy of the existing collection, but probably what we're going to do is filter or pull out or copy over only certain elements that fit some kind of criteria. Now, these aggregation functions, count, sum, max, min, and average, those do exactly what you would expect. They would, sort of count everything or sum all of the values in something, so long as it's some data type that has some notion of sum, or finding the max, min, or average of something that you can, basically have numbers in here. These end up producing a number. And so if you're familiar with parallel programming, these are really reduce operations. If you're not familiar with parallel programming, just think of it as aggregation, like max, min, sum, things like that. So moving on. So a select, this is sort of version 1. And I'm doing these all on primitive arrays, but remember, the thing you apply one of these select or where operations to, or one of these aggregate functions, doesn't have to just be a primitive array. It could be a list, it could be a set, it could be what else do we have? Well, those are queue, stack, array, anything like that. Can't be a dictionary because dictionaries are not enumerable or collections. The reason being, dictionaries have both keys and values. So if we're talking about enumerating over a dictionary, what are we enumerating over? The key or the value? Maybe we're enumerating over the pairing of them, the mapping of the key to the value, but then we're not enumerating over like numbers or strings or something like that. It's over some more complicated data structure. And so therefore, you can't just apply these functions in quite the same way. Anyway, so, here we've got 1, 3, 4, 5, right? That's our initial array. Let's think of it like this, 1, 3, 4, 5. I realize we don't usually draw arrays this way, but since we're really just sort of like projecting from sort of one collection to another, I kind of drew it with this syntax. So now we're going to say, okay, I want to create nums2, which is also going to be an integer array. But here, look what we're saying here. We're saying, well, from n in nums, select n times n. Now, if you're familiar with SQL, this looks a lot like SQL syntax for doing a select query. But that's not that's not the only way to think about it, but it's certainly a way to think about it. And if you're not familiar with SQL, well, let's think about what we're saying. Let's break this down. So we're saying from n in nums, right? So basically go through each n that's in nums. So n is going to, be 1, then 3, then 4, then 5. Select n times n. So this is the function n times n that we're going to apply. So you can see the new result here. Each thing has been squared. We're doing n times n. And then at the end of this, we're saying .toArray to sort of coerce the result. Whatever comes out of here isn't necessarily going to be an array. We're saying, well, convert it back to an array so that this assignment works. So select, that's a projection operation. And again, this is very close to what you might see in SQL syntax. It's not exactly SQL syntax, but it's certainly inspired by it. There's another way to do this, which is a different syntax. I tend to use this syntax more often, so everything's kind of the setup here the same. These will do the same thing. We're saying nums.select. Here we're directly invoking this select method, which you can invoke on, any collection in C#. And we're saying select. Now, what's going on in here? This is called a lambda. A lambda is a function, but it doesn't have a name. This arrow, this equals with this greater than sign, this is an arrow operation. It basically creates a lambda. So it's a function that says, okay, given some n, I want you to, on some parameter n, return n times n. So it's a lambda function. It's an anonymous or unnamed function. We could go and define a function like, public static int square, which takes int n and returns n times n or whatever. And then we could try to do a select where we try to pass that function in or whatever. We could do that, but that'd be super annoying. We can just kind of define on the fly what we want this to do. So lambda is a generic term in programming languages to mean an anonymous or unnamed function. And so this will do exactly the same thing as the previous example, but it's doing it with this explicit call to the select method. And what's the parameter of the select method is a lambda function. And so you can think of this as saying like, okay, take this array or this collection, really, because it'll work on any collection, and I want you to select stuff out of it. So do a projection operation where we take each thing n and convert that to n times n, and then that's going to be my result. Where is a filter operation? So, if we think about it, we got the same setup, but this resulting collection is smaller than the original collection. So what we're doing would say nums.where, so we're explicitly invoking this where method. This is also a lambda, but the result of this lambda isn't a number. It's not like n times n. It's actually true or false, right? So given n, we want to return n mod 2 equal 1. Well, n mod 2 is either going to be 1 or it's not. If it is 1, that's going to be true. If it isn't 1, that's going to be false. And what where is going to do is it's going to produce this new collection where we only have elements that make this lambda true. And that makes sense. N mod 2 equal 1, that's basically checking for odd numbers. 1, 3, 5, that's what shows up over here. 4 is not odd. 4 mod 2 is in fact 0, so that would make this false. So 4 doesn't end up over here. So that's why we say where is a filter operation, because you can use it to filter only things that fit this specific criteria. So again, with where, you're going to have a lambda function that returns true or false. Going back a slide, with select, you're going to have a lambda function that doesn't return true or false. It's going to return some value over here. And so the size of this collection, the resulting collection, should be the same size as the input the collection, the existing collection, the collection that you're doing the select operation on. Okay. Yeah, and I mentioned all of this verbally, that you're going to have this lambda function essentially should be a Boolean function, should return true or false. So this is where this collections hierarchy comes in. What do these things return? Select and where? What should they return? They actually return IEnumerable, because that's kind of all we need to know, is that it's something that you could enumerate over. Now, IEnumerable, luckily, has built-in methods to convert to array or to list. Because if something's enumerable, that means I can iterate over it. Well, anything I can iterate over, as I'm iterating over it, I could be like sticking everything into a list. So these are pretty trivial methods to implement. So here's where some more interesting C# syntax comes in. We can use var. We kind of read about this in our readings on C#, and we're like, where would this come in? Well, here's a great situation where it would come in. So suppose we've got some, integer array, and we're going to do a where operation. We're going to do some filtering because we only want to get out values that fit some specific criteria. So sounds great. We go ahead and do that. Well, suppose all we're going to do is iterate over this and, print it out. Well, if that's the case, I don't really care what type comes out of here. Like, I could make it IEnumerable or int or something like that. I can also just say var nums2. And if all I'm going to do is iterate over it, that's fine. So this is great for two reasons. One, it's taking advantage of the fact that IEnumerable, I can just enumerate over it. It doesn't really do anything else. So this for each loop is fine, but I don't need to worry about like IEnumerable and the angle brackets and int and whatever else with the generic types. I'll just say var. That's telling C# to do type inference. It doesn't mean that nums2 doesn't have a type. It absolutely does. It just means that I kind of don't care about the type that it is. I want C# to infer what type it is to do type inference, but not bother me with the details. And as long as I use nums2 in an appropriate way for the rest of the code, as long as I don't do things to nums2 that I can't do with whatever type var ends up being, I'm okay. Now, keep in mind that if I do something wrong with nums2, it will still be a compiler error. It's not dynamic typing. There is a dynamic keyword which basically turns off the type checker for particular variables. That's not what I'm doing here. I'm just saying, okay, something's going to pop out of here, and if I'm just going to do a for each over it, I'm just going to say var and let the type checker infer what the type is. It'll figure it out. Everything's fine. In some instances, it's certainly possible to write code where the type checker can't figure it out, and then you'll get a compiler error and be like, hey, var's not appropriate there. I can't figure out what type it is. You're going to have to tell me what type it is. But for something like this, C Sharp's going to look at this and be like, boom, this is going to be IEnumerable, and it's an IEnumerable for int. This for each loop's going to work out fine, and it's going to be great. So that's an interesting example of using var. Other really cool things you can do that are not directly related to Linq, but that are still really cool. You have an array.sort method. So given an array, you can just tell C# to sort it, right? You don't have to write the sorting code yourself. I've got an example of that. Join. This is really cool. This is a static method because I'm doing string. This is the string class.join. And then you give it the delimiter and a collection. And the collection is typically going to be like a list of, it can be like it's usually a list of strings, like some sort of collection of strings. And so what C# is going to do is take all of this stuff and produce a single string where you've got whatever this delimiter is in between. I'll just show you the example. It'll make it more obvious what is going on here. If I just actually show you the example, hopefully it's loading this and you can see this. So, you can kind of see I've got an array of strings, and if I take, I can do join on, this is a static method on the string class, and so I want commas in between everything. So if I go ahead and, run this, I should get dog, cat, bird, squirrel, which is great. So I've got this delimiter, which was comma space, separating everything out. That's a really, really useful thing to be able to do. Every language these days has some way to do join to, produce a string with some delimiter just in between all elements of a collection once they've been converted to a string. I hope it actually shifted over and let you see all of that. I don't know if it did. Sequence equals tells you if two sequences are equals. That's really useful. If you have two sequences, two things that are, I don't think they're just enumerable. I think it would have to be a collection, so it has some notion of order. Maybe it has to be IList. I'm not really sure. It'd be something to look up, but it's a useful method if you have two, ordered lists of things and you want to be like, are these equal? C# has a single method for that. You don't need to write nested for loops to figure it out yourself. Helper function. This is a really cool way to convert like an array or a collection or something like that into a string. So you could just be like, oh, I want to print an array out. Well, I could just, call the right line, do the join, everything's great. I'll just sort of get this. So this would be a really good helper function for when you're debugging and you're like, you know what, I've got a list or I've got an array or something like that, and I just need to print out this stuff all the time. You could just write this static method and use the static method rather than having to remember how to do join every time. Because join is great, but what's even better is to just be print and not even have to worry about joining. And I got a couple of other Linq examples. You can go ahead and click in and check these out. Cool. All right, nerds. That's your System.Linq tutorial. Good luck.